In this video, I will explain how to solve linear inequalities. So let's work through a couple examples. Let's say we have 4x plus 5 is less than 17. We want to figure out for what values of x is this expression true. So the way that we can do that is we can solve for x. So let's get x all by itself. To do that, on the left-hand side, we need to subtract a 5. So we'll subtract a 5 from this side as well. That leaves us with 4x is less than 17 minus 5, that's 12. Now to solve for x, we need to divide by 4. And we're left with x is less than, we'll divide this side by 4. 12 divided by 4 is 3. So x is less than 3. Any value that we plug in that is less than 3 into this original equation, it will be true. So if we want to write that in interval notation, we could write it like this. From negative infinity up to positive 3. And we'll use a parentheses because 3 is not included as one of the possible answers, as one of the possible valid answers for x. So x can be negative infinity all the way up to 3. If we wanted to draw that on a number line, we could do something like this. We could draw a number line where this side is going to positive infinity and this side is going to negative infinity. And if we have 0, let's say right here, and a 3 right here, we could draw an open circle at 3, since 3 is not one of the valid solutions, and we would just draw an arrow to the left here towards negative infinity to say that any value less than 3 on this number line is a valid answer. All right, let's check out another example. Let's say we have 1/5 x minus 9 is greater than or equal to 21. So again, we want to figure out for what values of x is this expression true. So the way that we do that is we can solve for x. So let's add a 9 to each side, plus 9, and that will leave us with 1/5 x is greater than or equal to 21 plus 9, that's 30. And now to get x by itself, we can multiply this side by 5. So if we multiply by 5, 1/5 times 5 is just 1, so we'll be left with x is greater than or equal to 30 times 5, that's 150. So the answer is x is greater than or equal to 150. Now if we wanted to write that in interval notation, we could write a bracket to indicate that 150 is part of the solutions, 150 all the way up to positive infinity. So if we plug in the value 150 or greater into this original expression, it will be true. Now if we wanted to express that on a number line, we could do something like this where we draw the number line. This is going to positive infinity, this side is going to negative infinity. We have 0 right here, and let's say 150 is somewhere over here. We would draw a closed circle at 150 to indicate that 150 is a valid answer. We're allowed to plug in 150 to that expression, and anything greater than that. So 150 or greater. Let's try another example. Let's say we have negative 8 is less than or equal to 5x plus 2 is less than 17. So once again, we want to get x all by itself. So to do that, we can subtract a 2. And whatever we do in this middle term right here, we have to do to the outside terms as well. So we'll subtract a 2 from the negative 8, and we'll subtract a 2 from the 17. So that leaves us with negative 10 is less than or equal to 5x, which is less than 17 minus 2, that's 15. Now to get this x all by itself, we need to divide by 5. And if we divide this middle term by 5, we have to do the same thing to these outside terms. Divide by 5, divide by 5. So negative 10 divided by 5, that's negative 2. So less than or equal to, here we're just left with x, which is less than 15 divided by 5, that's 3. So our solution is x is greater than or equal to negative 2 and less than 3. If we wanted to write that in interval notation, we would write it like this. A bracket at negative 2, since negative 2 is less than or equal to, so x is allowed to be negative 2. That's part of the solution. And it can go all the way up to 3. And here we'll write in open parentheses. Since this is a less than sign, it means x is not allowed to be 3. It must be less than 3. So our solution is negative 2, comma 3. If we wanted to draw this on a number line, we could do this, where this side is stretching towards infinity, and this side is stretching towards negative infinity. And let's say we have negative 2 right here, and we'll say a 3 right here. We can draw a closed circle at negative 2, since negative 2 is one of the valid answers. And we can go all the way to a positive 3 where we draw an open circle. Because remember, 3 is not one of the answers. X is less than 3. So that's how we would represent that on a number line. All right, let's try one last example. Let's say we have 5x plus 2 is greater than 12, or x plus 3 is less than negative 4. So we want to solve for x for both of these expressions. So let's check out this first one. We have 5x plus 2. So to get x by itself, we can subtract 2 from each side. Minus 2, minus 2. We're left with 5x is greater than 10. And to get x by itself, we can divide by 5 on each side. So we get x is greater than 2. And then remember, over here we have x plus 3 is less than negative 4. So let's solve for x. So we can subtract a 3, and we're left with x is less than negative 4 minus 3, that's negative 7. So our answers are x is greater than 2, or x is less than negative 7. So the way that we would write that in interval notation is negative infinity to negative 7. Remember, we use a parentheses because it's less than. There's no equal sign. And then we say union with 2 comma infinity. So x is allowed to be any number from negative infinity up to negative 7, but not including negative 7, along with any value between 2, not including 2, all the way up to positive infinity. So if we wanted to draw that on a number line, we could draw it like this, where this side is extending towards infinity, this side is extending towards negative infinity, and we have, let's say, a 0 right here, and a negative 7 somewhere out here, and a 2 over here. And we would draw an open circle at negative 7, and it would extend towards negative infinity. So we're saying x is allowed to be any number less than negative 7. Or we draw another open circle at 2 and extend that towards positive infinity. So we're saying x is allowed to be any number greater than 2. So that's our final answer on that one. Thanks for watching, guys.